All right, so I'm going to start pretty much where I left off last time, but it's the topic of today's reading as well, so I'm just going to do that everything together. Um, um, right, so basic statements. Basic statements are supposed to be kind of like protocol sentences or observation statements. Um, they're the empirical statements that we're going to use to test scientific theories. But actually, there's two different ways we're going to use them, and that's what I was kind of rushing through at the end last time. And it's important to keep them separate. So, number one, we're going to use all possible basic statements to decide whether a certain theory is falsifiable. So to decide whether the theory is falsifiable, roughly speaking, you compare it to all the possible basic statements, right? Like, in other words, all the possible items of empirical evidence, something like that, and you see if it rules out any of them. If it rules out any of them, then it's falsifiable. But then the second way we're going to use it is to actually falsify theories, right? So, it's this thing again. All right, hold on, because I just drew stuff on the board, but it's not. It's frozen. There we go. All right. So, so we're going to use the possible basic statements to decide if a theory is falsifiable, but then we're going to use actual basic statements to put it better, that have been accepted, to decide whether the theory is actually falsified. Right? Obviously, we can't compare the theory to all possible basic statements if we're going to decide if the theory was falsified, because if it's falsifiable, then it is inconsistent with some of the possible basic statements. We want to know whether it's inconsistent with any of the basic statements we've actually accepted. If it is, roughly speaking, that's when we're going to reject the theory, consider it falsified, and hopefully adopt a better theory in its place. But I said roughly speaking because, and I emphasized this last time and emphasize it again, Popper, unlike the actual Popper, unlike some versions of the mythical Popper, doesn't say that we reject a theory every time we get one observation that contradicts the theory. On the contrary, he says that normally we ignore stray observations. So we reject the theory when a falsifying hypothesis is accepted. So the falsifying hypothesis is going to be one that is that. So we have our falsifying observation. I'm going to talk about this in more detail later, but we have our falsifying observation. The falsifying hypothesis is going to imply that falsifying observation, whereas that falsifying observation will be inconsistent with the original theory. So that's how we use the accepted basic statements to falsify the theory. We make some observations that contradict the theory, and we have a hypothesis that implies those observations. And at that point, we can decide to accept that falsifying hypothesis and therefore to reject the theory. But as I was saying at the very end last time, that that process leaves a lot of points where we have to make decisions. Not just that we, as I'll talk about later, we have to decide which basic statements to accept, but we have to decide when we get something that looks like falsifying observations, we have to decide whether to adopt a falsifying hypothesis, and if so, which one. Okay, so that's an overview of what basic statements are going to be used for. Are there questions about that? Okay, so now I'm going to talk about each of these two things separately. But to begin with, and this is basically the way Popper organizes it as well, I'm just going to talk about the logical situation. Now, why do I say just the logical situation? I mean, without asking what kind of statements basic statements actually are. Without asking what kind of concepts or predicates are going to be used in basic statements. So the theory, and also without asking when we're going to accept basic statements. Just assuming that there's a class of possible basic statements. We've decided which statements are possible basic statements, and there's a class of accepted basic statements that we've decided to accept, never mind how. So the theory, remember, is going to look something like this. Only, I think when I wrote this before, I wrote this with X instead of K. This is a K. I'm writing K. That's the letter that Popper, when he discusses this, uses to stand for specific spatiotemporal coordinates, or a specific spatiotemporal place. So when you write it this way, I guess you could be thinking of the predicate A as meaning, so AK means the thing at K is a swan. And BK might mean the thing at K is white. Right? So this theory says at every place such that the thing at that place is a swan, the thing at that place is white. Or in other words, all swans are white. But I'm writing it this way, quantifying over spatiotemporal locations instead of over things, because for the same reason Popper does that, because it's going to allow me to discuss what role strict universality plays here when I get to that. All right, so from this theory directly, you can derive singular statements like this. Some of this is stuff I already talked about last time, but I guess I'm using this. Right, where suppose that C stands for some particular spatiotemporal location. So this says, if the thing at C is a swan, then it's white. Or in other words, it says, either the thing at C is a swan, either the thing at C is white, or it's not a swan. Right? These two things mean the same thing. I hope you remember this from Phil 9 or whatever. But yeah, if not, you can see why they mean the same thing. Um, when I say if it's a swan, then it's white, I mean either it's white or if it's not white, then it's not a swan. So, therefore, the theory only implies something I can check about spatial-temporal locations where there is a swan. For all the other places where there is no swan, it doesn't say anything. Or to put that same thing in a more positive way, given the initial condition that there's a swan at sea, the theory plus the initial condition, I can infer from the theory plus the initial condition that there's something white at sea. So the basic statements are going to be singular statements, but they're going to be singular statements like this, and not singular statements like this. Now, I mean, as I said before, when I say like this but not like this, obviously I could just define a predicate Q, right? I could define Q K to mean this, right? So in other words, going with what I was saying that A and B mean, I could say there's a Q at K means there's something that's either white or not a swan at K. Counting nothing is also as something. Whatever. Counting an empty space as something. Right? So I can't tell just from looking at like the way it looks in the logical symbolism whether it's this kind of statement, the kind that says something that I can test, that I can see if it's true at the location C, or whether it's this kind of statement that I can't see if it's true unless I have the initial condition. So in other words, when I say it's going to be like this and not like this, that depends on a decision about what predicates are going to count as observable predicates. This one, Q, is not. Right? By looking at a place Q, by looking at a place, I can't tell whether Q is true of that place unless there's a swan there. So it's not by itself an observable predicate. Okay, I'm sorry. I know that last thing I said might be more confusing than helpful, but I'm afraid if I don't say it, that could also be confusing. So is there a question about that? Why I just said all that stuff about Q? All right. Okay, so getting back to this. So the basic statements are going to be like this, right? So an example of a basic statement is going to be the thing at C is white. So the theory doesn't imply basic statements by itself, right? The theory implies things like this that are not basic statements. doesn't imply things like this that are basic statements. But in general, the theory, if it's empirical, implies basic statements given some other basic statements, the initial conditions, right? So, given the initial conditions, this theory implies the statement B of C. There's something white at sea. Like to make this precise, what you have to say is, and I'll show you this in the book. So this is in section 21, back in chapter 4, on page 65. In this way, we are led to the demand. In this way, we are led to the demand that the theory should allow us to deduce, roughly speaking, more empirical singular statements than we can deduce from the initial conditions alone. Right? So from the initial conditions alone, we can deduce certain singular statements. So like from AC, we can deduce AC, for example. And we can deduce AC and BC or not BC and all kinds of other statements just from AC by itself. But from AC by itself, of course, we can't deduce BC, right? That is, this thing obviously is not logically valid. These are just two different predicates. And yet, when we add the theory, then we can deduce BC from AC, right? So the theory enables us to get some consequences out of the initial conditions that we couldn't have got out without the theory. To get some basic statements, that is, some empirical consequences that we couldn't have got without the theory. So, right, so that rules out theories that are tautological. Right, if the theory itself is logically valid, that is, it's necessarily true, then it won't allow us to get any more consequences at all out of anything. And it also rules out theories that are metaphysical, that allow us to get consequences out of initial conditions, but not observable consequences, not basic statements. Right? So that's basically what we mean by saying the theory is an empirical theory. The theory is an empirical theory if, given certain initial conditions, we can get new consequences out of those initial conditions thanks to our theory. And that criterion is exactly the same as the criterion of falsifiability. Why? Because, so the theory, if the theory implies this, in other words this, then the theory is inconsistent with the negation of this. So the negation of this is obviously. Now again, you might remember this from Phil 9, or you might not, but this is called De Morgan's law. When you move the not, distribute it over this changes from or to and. So the negation of this is this. Double not AC and not BC. I mean, it's not hard to see why that's true if you think about it. um, that, you know, P or Q means at least one of these is true. So not P or Q means neither of them is true. In other words, not P and not Q, right? So of course these two nots cancel each other, and this is the negation. It says there's a swan at sea and it's not black. That's a basic statement. Sorry, it's not white. Sorry. There's a swan at sea and it's not white. That's a basic statement. Although the theory doesn't imply any basic statements, it does contradict some basic statements. It rules some basic statements out. So if the theory is empirical, then it's falsifiable. I guess I should show the other way around. If it's falsifiable, then it's empirical. I think that's easy to do, but I didn't think about it in advance, so I won't try. I'll just get confused. But anyway, you can see why this criterion, if it's going to be empirical in this sense, it will have to be falsifiable. And obviously now, I mean, I'm not really going to do something with this, but I'm going to mention it because Popper talks about it to some extent. Obviously, if the theory rules out this, that there's a swan at sea and it's not white, it's going to also rule out the existential statement. Somewhere there is something that's a swan and not white. So this statement also contradicts that one. And that's a good result. That's what we want to see, because not that it's surprising, right? I mean, I didn't do anything complicated here, but this is the result we want to see, because this statement actually is just the negation of this one, right? The negation of, for all k, if there's something at k, if there's a swan at k, then it's white, is there exists some k such that there's a swan at k and it's not white. All right, so theories falsifiable theories always rule out what Popper calls pure existential statements. But the pure existential statement is not the way we're going to test the theory, right? This statement by itself is not testable, not falsifiable, not testable in any way, because, you know, I just have to keep on looking everywhere to find this swan that it says is somewhere. And no matter how long I look, I don't know that I might not find it eventually, right? So it's this kind of statement we're going to be using to test theories. Okay, so that's the way possible basic statements are going to be used to determine whether theories are falsifiable. And I guess yeah, let me actually say now right away. So obviously, as I said, it's dependent on some way of telling what kind of things A and B are allowed to stand for. They have to stand for observable properties of spatiotemporal regions, or what Popper would call observable occurrences. Right? It's an occurrence rather than a thing because it's a spatiotemporal region. It's at a certain place at a certain time, right? So, I mean, when I say there's a swan at sea, I mean there's a swan in place so and so at a certain time. That's like an occurrence. Okay, so anyway, these have to be observable occurrences. Um, how do we define observable? So Popper says, well, it's not definable. I'm not going to define it. It's an undefined term that you have to understand to understand this theory. Now, that's not very helpful, but he says a little bit more about it. He says, well, um, it's not a psychological property, but it can be explained using psychological properties. So what psychological property would it be? Well, in other words, you might think that to say that a certain occurrence is observable is to say something about human beings, and in particular, I guess, about their minds. That's why it's psychological, namely that they're capable of observing this occurrence. Um, so, uh, um, so the psychological explanation is something like, well, by observable is in observable predicates are intended to be the kind of occurrences that we can observe. But Popper says you could also give it a physicalistic explanation. You can say, well, observable occurrences are supposed to be motions of macroscopic bodies. Now, I'm not sure that macroscopic isn't itself also a psychological term, because there's that hidden relativeness to us, right? What is macroscopic? But maybe not. Maybe it's defined in terms of something having to do with the negligibility of quantum effects or something. I don't know. Anyway, but that's supposed to be a physicalistic explanation. Observable occurrences are the kind that involve macroscopic bodies moving around. Is that really true for is white? I mean, I think, maybe it isn't, and maybe is white has to be replaced by when I point my light meter at it, the pointer moves to this position or something like that. But in any case, those are just explanations of what kind of thing we have in mind, but those are not definitions. Um, and because what it's going to turn out is that an observable predicate, an observable occurrence is just one that we expect to agree. We expect to be able to agree on whether it happened or not. That is, we expect everyone who's around to be able to agree on whether it happened or not. Right? Everyone who's present, so to speak. So, it could be something that you need lots of instruments to determine, but we're all used to using those instruments. So we're pretty much in agreement on what they show. And then that would be a perfectly good basic observable occurrence, or in other words, that predicate would be perfectly usable in a basic statement. Okay, there is nevertheless a problem with this, and I think when we read Putnam's critique of Popper, coming up pretty soon, we'll see Putnam taking advantage of this, which is that Popper wants to say, well, observable isn't definable, but this is kind of how I'm using it. But isn't there already a perfectly good definition of observable that we're already using? Right? Isn't observable something we can observe? Call that psychological if you want, but anyway, isn't that what it means? How can you just use it to mean something else? I think, in effect, that's what Putnam is going to ask, and it's similar to the way he criticized Carnap, I believe. Okay. Um, so that's falsifiable. Now I'm going to talk about falsification, unless there are questions about falsifiability. Um, okay, so to understand what Popper says about actually falsifying theories, um, you have to remember, first of all, that the theory, I guess I'll write the theory up here again. Here's our theory. The theory is supposed to be strictly universal. Now, what that means is that something like we're understanding these predicates as being things that could be true for any k. They could be true or false for any k. Or I guess maybe to put it better, we're understanding this as something that could be true or false at any k. Right? As opposed to if a theory like all pens on my table are black, assuming that on my table is something that can only be satisfied by this table here, that again you can't see, but it's there, that in other words, it's not like a description that something on another planet could satisfy if it's enough like this table. But no, it has to be this one, right? So then if I say all pens on my table are black, then that's something that um, you know can only be false for k on my table. Everywhere else, it has to be true because there isn't anything that's on my table anywhere else, and there can't be. Right? So assuming that our theory has strict universality, then it's never going to rule out something like right at C there is a swan and it's not white. I guess it is pretty confusing that the letter B stands for white. But, oh well. It's too late now. All right. So at C there's a swan and it's not white. If it rules out something like this, it's also going to rule out a whole bunch of other basic statements. I mean, I guess, this much is just a matter of logic, but it's the strict universality that means that, like, this makes sense everywhere. um, right? So, the theory, all swans are white, rules out that there's a swan here and now that's not white. But if it rules that out, then it also has to rule out for everywhere, always, that there's a swan there that's not white. And assuming that swan and white are being understood as things that could be instantiated everywhere at every time, again, not the way biologists actually use the species term swan, or its uh, Latin equivalent, whatever that is. um, so, but if we use swan as like a description that could be true of something at any spatiotemporal location in principle, um, then um, the theory rules out something that could be true in principle anywhere at any time. Um, and this has to do with all that complicated stuff that Popper is talking about in section 23 about events versus occurrences. Um, Occurrence is a weird word for what he means. I mean, sorry, occurrences versus events. Event is a weird word for what he means there, but it's actually a good translation in the sense that he used in German a weird word for what he means there. But in any case, be that as it may, um, I'm not gonna like go into that all that stuff with the circle and whatever, but that's basically what he's talking about. That when the theory rules out a particular occurrence, it also rules out the set of everything that's like that, only at a different place or time. Okay, so I mean, in particular, because of this, and so far, I mean, what I'm going to say next doesn't add anything to what I just said. On the contrary, it just arbitrarily narrows it down. So suppose I have some predicate C. Then if the theory rules out this, that there's a swan at sea and it's not white, it also rules out all statements like this. Right? That is, C is true of K, and there's a swan of K, and it's, sorry, this should be a K. And whatever is K is not white. I mean, that's obvious, right? It doesn't matter what C is. Um, if it if something contradicts this, then it's going to contradict this. Um, but what this means is that any falsifying observation can be made into the prediction of a falsifying hypothesis. So how would I do that? Well, I find some C such that, this is confusing. Maybe I shouldn't have used C. Let me call this D. I find some D such that DC is true. Right? Like, for example, DK might mean the spatiotemporal location K is in Australia. Suppose that the non-white swan I found is in Australia. So I not only have found an example of swan that's not white, but I found an example of a swan that's not white and is in Australia. And my original theory rules out this and therefore also rules out that, right? I mean, obviously, if it says that there can't be a non-white swan anywhere, it also says there can't be a non-white swan in Australia. But now I can form a falsifying hypothesis which predicts this. I mean, of course, like here's an example of a falsifying hypothesis which predicts this. No swans are white, right? No swans are white. Well, sorry, no, it doesn't predict that, does it? Oh, sorry, no, okay. Um, which predicts this given some initial conditions. Right? So here's an example of falsifying. Obviously, this is a basic statement. No theory, no universal statement, no hypothesis in that sense is going to imply this without initial conditions. But here's one that does imply it with some initial conditions. No swans are white, right? So just you put a not in there. Now, because obviously this theory implies this basic statement. Sorry. This theory, with these initial conditions, implies that the thing at C is not white. It implies this. And because it implies this, and we know this was the initial condition, it implies this with that initial condition, right? So if there's a swan at C, then this theory implies that there's a swan at C and it's not white. And if C is in Australia, then this theory implies, given that initial condition, that there's something that's in Australia and is a swan and is not white. So an example of a falsifying hypothesis would just be the opposite of the theory we were trying out before, right? Our theory was all swans are white. The falsifying hypothesis would be no swans are white. But that's not usually the kind of falsifying hypothesis we're going to use. Why? Because we only accepted this theory in the first place because it passed various tests, right? So, we must have found a lot of swans that are white. Sorry, let me bring it back to the original theory. Right? We must have found a lot of swans that are white if we accepted this theory. Not because we're building it up by induction, but because we're testing it. In order to test it, we have to find swans and see if they're not white, then the theory would be falsified. So, right, so our falsifying hypothesis is not going to be no swans are white because we wouldn't be talking about this theory at all unless we already knew that a lot of swans are white. But our falsifying hypothesis might be something like this. I need to make more space here somehow. So I use this. I'm probably going to regret it. Right, so this is the theory. And this is the falsifying hypothesis. Right? The falsifying hypothesis says that every swan in Australia is not white. Now, the falsifying hypothesis is not actually inconsistent with the theory. For that matter, even the one I discussed before isn't inconsistent with the theory, right? No swans are white is consistent with all swans are white. They could both be true if there are no swans, right? If there are no swans at all, then all swans are white and no swans are white. But again, as I was saying, if we have tested this theory and it's passed tests, then there must have been some swans that we tested. And under those conditions, that falsifying hypothesis not only contradicts the theory, but it's already been ruled out. There's a question. Is it possible to accept a theory if there's always the possibility of finding a falsifying example at a later time? Yes, and you should only accept the theory if there's always a possibility of finding a falsifying example at a later time. That is, you should only accept it as an empirical scientific theory if you're open to finding a falsifying example at a later time. That's the methodological rule that Popper is laying down. Otherwise, you're accepting the theory dogmatically, right? You're saying, I think this is true, and you can't convince me otherwise, at least not by empirical evidence. So there always should be, but if the theory is strictly universal, then there always will be, right? Because we never will have checked all K. If the theory is only numerically universal, there's a risk that we'll completely exhaust it. We'll check every case, right? And then there'll be no more testing it anymore. And therefore, that's not what scientific theories are like, right? So all pens on my desk are black. After I've checked every pen, there's no possibility of falsifying it anymore. I mean, there's no possibility of falsifying it given that we've accepted those basic statements. Later, we might reject one of those basic statements, and then it could be falsified. But that's not what we're talking about, right? We're assuming that there's an accepted set of basic statements, and if the question is, could we always accept a new one outside that set that would falsify the theory? And the answer is yes. Okay, did they answer the question? I'm going to assume it did. All right. So similarly, this falsifying hypothesis doesn't by itself contradict the theory, actually, right? Because if there are no swans in Australia, then it can be both true that all swans are white and all swans in Australia are not white. It's also true that all swans in Australia are white, if there's no swans in Australia. Right? It's true both that they're all white and that none of them are white because there aren't any. Okay, but again, under the condition we're adopting this falsifying hypothesis, the condition is that we found something that looks like falsifying evidence. Right? We found that at a certain C, there's something that's a swan and it's not white. And it so happens that that C is in Australia, so we've also found this. Right? So we know that given that this observation has been made, in that case, these two are inconsistent. Right? Because if this observation has been made, then there's at least one swan in Australia, and therefore it has to be either white or not white. This says it's white, this says it's not white. So under those conditions, they're inconsistent with each other. So, so what I report, methodologically speaking, what I should report, or the type of report that should be acceptable for me, by the scientific community is not something like this, a singular occurrence, but something like this that well, I guess, I mean, actually, you can write it this way. Maybe I should. I guess, let me use Popper's notation. So Popper says, call the occurrence let me just I guess I should add to. Yeah, all right, should add to. All right, that noise made the cat look up. All right, so call the occurrence P sub C this statement. What I report is not the occurrence. What I report is that there's been some member of this class right? So instead of saying at such and such a time in Australia, at such and such a place, I saw this swan and it was not black, I say, I've observed an instance of this rule, of this, no, I've observed an instance of this type. The type is that at some place in Australia, there's something that's a swan and not black. That's what Popper calls an event. I said I wouldn't get into that, but I am getting into it a little bit, right? So instead of reporting the occurrence, I report the event. Of course, I say that it was at sea, but right, so I say at sea there was an event like this, a swan in Australia not white event. Instead of just saying at sea in Australia there was a swan and it wasn't white. Now, what's the difference between those two, you might ask? Like, why am I beating on this so hard when, like, aren't those just two ways of saying the same thing? But, I mean, they are two ways of saying the same thing. But there are two different ways of taking that thing methodologically. The first way just says, this happened. That's why I don't believe this theory anymore. The second one says, this kind of thing happened. That's why I don't believe this theory anymore. And if you want to come into agreement with me, set up the same conditions I did, and you'll see the same thing. In other words, reporting the event is reporting something replicable. I'm not just saying that once upon a time I saw a swan and it wasn't white. I'm saying I saw a swan and it wasn't white. And I'm guessing that it was because it was in Australia, so to speak. Not because in some like sense of like some, being in Australia pushed it. But because in the sense of what Popper calls a causal explanation. Right? I've determined that, I'm guessing, my hypothesis is that being in Australia explains why it's not white. And so now I'm proposing to the scientific community test my falsifying hypothesis against our old accepted theory. Go to Australia, find a swan, and see if it's not white. And if the falsifying hypothesis starts to pass tests, at that point we're going to reject the old theory. You know, and why not reject it as soon as this is observed? Or as soon as this is observed, because that already contradicted the theory. It's a methodological point. It's not a good idea to, you know, because there's always stray observations that no one can explain. When we don't reject the theory in the face of those stray observations, what we're implicitly doing is saying, well, you know, there'll be an explanation for it probably someday. We'll find out that that basic statement shouldn't have been accepted. You know, I was hallucinating, whatever. Or, you know, we'll find out that there's some way in which the theory is consistent with that observation. It's hard to think of an example in that particular case, but in more complicated cases where the initial conditions are might be really complicated, we could say, well, you know, we didn't realize that this initial condition wasn't fulfilled or something like that. So, but we don't have an actual explanation, so we're just putting that off. And Popper's point is that methodologically speaking, that's the right thing to do with stray observations. It's the wrong thing to do with falsifying hypotheses. With stray observations, we should just say, oh, well, who knows why that observation came in, but we like our theory, it's passed lots of tests, whatever. That will be taken care of later. But once you get a falsifying hypothesis, then you have to say, and it's been accepted, meaning it's been tested, and it's passed its tests, then you have to say, well, look, that theory has to be abandoned. Now notice, I said that these were two different ways of saying the same thing. That's sort of true and sort of not. I mean, they're two different ways of saying, what are two different ways of saying the same thing is to say that that this event occurred at sea. If this event occurred at sea, that's the same as saying that that this is true. But there's a lot of other events that it would also be true to say occurred at sea, if this is true. Right? Like, you know, maybe it's also true that the swan I saw at sea was eating kangaroo poop. Call that E. I guess the swan would probably eat that. I don't know. Anyway, so, right, call that E. So this is a different occurrence. Call this Q. Well, okay, no, sorry. I mean, no, so this might be the same occurrence. It'll be the same, right? I mean, it will be the same occurrence in the sense that it's the same swan at the same place that's not white. right? We're talking about the same thing that happened in the same spatiotemporal region. We're just mentioning a different characteristic of it than we did before. So as far as the occurrence goes, this is just a different way of describing the same occurrence. But of course, the event is different, right? Because when we take out C and put in K, now we're not talking about about a swan in Australia not being white. We're talking about a swan that's eating kangaroo poop not being white, right? So in other words, yeah, actually, maybe I should have put it this way. Call this Q. Then in this case, QC is equivalent to PC. There's only a swan that's in Australia that's not white at C if, it's not exactly right either. They're not logically equivalent. But anyway, they're the same occurrence. Maybe I should have gone more into that complicated stuff. That would make it possible to explain this. But these two are the same occurrence, but the events are not the same. Right? The events are not the same because, some of the members of this event are occurrences of a swan not in Australia eating kangaroo poop. And some of the occurrences of this event are occurrences of a swan in Australia that's not eating kangaroo poop. So when I report my observation as an event rather than an occurrence, I'm guessing what the right event to report it as is. Or in other words, I'm guessing what the right falsifying hypothesis is. Right? If I report it as an instance of swans in Australia not being white, then this is the falsifying hypothesis, that all swans in Australia are not white. If I report it as an instance of swans eating kangaroo poop not being white, then the falsifying hypothesis is that all swans that are eating kangaroo poop are not white. And based on that guess, then people are going to go out and try to test a different falsifying hypothesis in order to replicate my observation. So if I guess wrong, they're going to be testing the wrong thing. But Popper says, yeah, that's what it's like. Or as he puts it, observation is impregnated with theory. Observation is already theory-laden. Whenever I report something, I'm never just reporting everything that happened at sea. Right, so he imagines, and he thinks that Carnap and Neurath are imagining someone sitting at sea and being given the instruction, write down in your protocol everything you sense, everything you observe. And he says, how could you do that? How would you know what to write in that protocol? You need some guidance from a theory, and a theory is a hypothesis or a guess as to what is reportable. You're not going to write in your protocol. You might write, there's a swan at sea, it's in Australia, it's eating poop. But you're not going to write, there's a swan at sea and it's grew. Right? You're not going to write, there's a swan at sea and an hour ago a black raven flew past. Why aren't you going to write those? Because you don't hypothesize that those things are relevant. So in here somewhere, I think, is supposed to be Popper's answer to Goodman. But whether it will work or not is a complicated question. Okay, so all of that is the discussion of the logical situation, basically. Are there questions about that? Both about how possible basic statements are going to be used to decide if a theory is falsifiable, and how accepted basic statements are going to be used to decide when to reject a theory? Okay, so a lot of that was stuff from chapter 4, which is bad because I'm already more than halfway through the lecture, but some of it was also from chapter 5. Popper splits his discussion of this into different places. Um, um, but in any case, all of that obviously is only going to work if we know what basic statements are like and when we should accept them. I mean, specifically for falsifiability, we need to know what they're like, right? Because we need to collect the class of all possible basic statements. For falsification of theories, we need to know when to accept them, because we perform this crucial experiment between the theory and the falsifying hypothesis, and we need to, the theory says white swan, the falsifying hypothesis says non-white swan, and we need to accept one of those basic statements. So I'm going to start with the second one, when to accept basic statements. And there's an apparent problem with this, an apparently very serious problem, which Popper is going to claim actually is not a problem for his view. Although he's going to say the analogous problem is a problem for Carnap and Neurodt's view, right? So this is a way that his approach is supposed to be better than their approach. What's the problem? Well, so we're going to test scientific theories using basic statements. We're going to accept scientific theories when they survive tests in terms of basic statements, and we're going to reject them, given a falsifying hypothesis, when they fail to survive tests in terms of basic statements. So given that theory we had before, which I don't feel like writing down yet again, but maybe I should. Given that theory we had before, we're going to test it. We're going to find places where there are swans, so we supply the initial condition, and we're going to see whether the thing that's there is white or not white. And if it's white, then the theory has passed that test. Of course, it doesn't mean the theory has been shown to be true. Popper says it hasn't even been made more probable, let alone shown to be true. But it has passed a test. On the other hand, if the thing that's there turns out not to be white, then it's time to start looking for a falsifying hypothesis, because maybe the theory should be rejected. But in order to complete this test one way or the other, we have to accept the basic statement, either BC or not BC. Now, we accept theories when they pass tests. When do we accept basic statements? And it seems like the answer should be when they pass tests. In other words, in order to accept one of these, don't we have to test it? So this leads into what Popper calls Fries's trilemma. Two M's in trilemma? I never remember how to spell lemma. All right. I wrote it here with two M's, but I could have misspelled it here too. All right, anyway, as I always say, I wish I could have a whiteboard with a spell checker. All right, so never mind who Fries is. I mean, actually, it's interesting who he is. One of the many things I tend to read someday is this long book that Popper cites here by Fries. But anyway, never mind who he is. He's just some guy. But and I don't think he proposed the trilemma in exactly this form. I think Popper is getting this out of him. But this is the trilemma. So you might think you should only rationally accept a statement if you know a reason for it. Now, know a reason for it. I'm going to leave that deliberately vague, but it's going to make a difference whether knowing a reason for it means knowing something that implies that it's true, or whether knowing a reason for it means not knowing something that implies that it's false or something like that, right? But anyway, so you might think you should, maybe I shouldn't even say that. I mean, Fries's trilemma, the way Popper expounds it, and the way I think Fries intended it, relies on justificationism. So, I mean, it's really, Popper is going to come back against this and explain how falsificationism escapes the dilemma. So let me just say, so you might think that you should only rationally accept a statement if you know something that implies that it's true. That seems to make sense, right? Isn't that reason is for deducing things from other things? So to rationally accept a statement is to accept it because you know something implies that it's true. But Fries and or Popper adds, statements are only implied by other statements. And this is a little bit of a tricky point. Like, you might think that the statement, this pen is black, is implied by the blackness of the pen or something like that. But that's not right. Implication is a relationship between statements, not between properties of pens and statements. Right? So statements are only implied by other statements. And so it seems like we only have three alternatives here. The first alternative is that, after all, some statements can be rationally accepted with no justification. And this is what Popper calls dogmatism. Again, I don't know if Fries introduces this terminology or not. Popper calls this dogmatism. Dogmatism, again, means that there's some statements that it's rational to accept even though I have no justification for them. The second one is infinite regress. It's only rational to accept statements that are justified. They're only justified if I know something that implies them. The thing that I know that implies them has to itself be a statement. If I know it, that means that I, rationally justified in accepting it. So I must know some other statement that implies it, and so on and so forth. And the third option, I mean, so far, this should be kind of familiar, right? Like, just saying that if everything has to be proved from something else, then you get an infinite regress. So it seems like your only alternative is that some things don't have to be proved. You can just assert them. But Popper adds a third alternative, and this actually turns out to be the most important one, which he calls psychologism. Now, I guess, like, generally speaking, this third alternative is this, that some statements are justified, but they're not justified because they're implied by something else we know, but they're justified in some other way. But, the reason he calls it psychologism is because the other way that people typically go to is they're justified by my experiences. I can see that they're true. Or anyway, in some way or other, I experience their truth, right? Maybe not by seeing, but by some other kind of experience. I experience their truth. In German, we say, I have an experience of their truth. The word that can be translated as experience there is Erlebnis. It comes from Leben, which means to live, right? Like an Erlebnis is something that you live through. It's something that happens to you. It's experience in that passive sense. I have an experience. In German, there's another word, Erfahrung. Which also has to be translated into English normally as experience. This is an F. Right? Fahren means, well, actually, in modern German, fahren means to drive, right? So you may, I don't know if this ad campaign is still around, but I know that Volkswagen had a campaign using the German word Fahrvergnügen, which means like driving enjoyment of driving. But originally, like it's a cognate of the English word to fare, right? Like farewell, right? Like how did you fare, right? So Erfahrung is something that you do. It's like you go around experiencing things. So it's often a dilemma, not a trilemma, but a dilemma, how to translate these two things. And Popper apparently decided it was impossible to get a good translation because he just pops for experience for both of them. But when he's talking about experiences as something that implies psychologism, he's talking about these passive experiences. So, right, and so this is psychologism because I'm saying that rather than depending for its justification on some action of finding things out that I have to do, it depends for its justification on something that happened to me. So Popper's claim is that, so if you think that to rationally accept a statement, if you're a justificationist, meaning you think that to rationally accept a statement is to accept it with justification, then Popper says these are your three alternatives. And he claims that Carnap goes for this one. And Neurath goes for this one. In the formal mode, as he puts it, right? So Carnap, rather than saying that there's certain sentences that are justified by experiences, he says there's certain sentences that we adopt based on our experiences. Protocol sentences, observational sentences. And then those sentences can't be challenged because to challenge them, I would have to examine the premises and see if it really implies that statement or not, but I can't, right? I mean, a premise is someone's subjective experience. So those statements can't be challenged. This is obviously is Carnap's early view, not his later view after he talked to Popper about this, in addition to reading Neurath. Um, right, that the protocol sentences are sentences that are introduced into our system without justification, but without explicit justification, without syntactic justification, without following from some other statement of the system. But Popper says it's not dogmatism, it's psychologism, because they are supposed to be justified, really. It's just they're justified by experiences. By the way, I don't think Carnap would agree with that, even in the Aufbau. I don't think Carnap would agree with that. But that's Popper's interpretation of Carnap. Neurath, on the other end, he says, so Neurath realizes, wait, there's no such thing as sentences that can't be challenged. Right? Just because I wrote down in my protocol, I saw a blue sphere then, doesn't mean it's true. So Neurath says, protocol sentences can also be challenged, and sometimes we'll delete them from the protocol. But, and again, this is Popper's interpretation. I'm not sure, I feel like Neurath would not accept this, but anyway, this is Popper's interpretation. But there's no rules for when to do that. There can't be rules for when to do that, because if there were rules for when to do that, then we'd be in this situation, right? We'd be asking, well, so were you justified in accepting that protocol sentence or not? So Popper says Neurath, and it's funny the way he puts that. He puts this. He says Neurath throws empiricism overboard, right? Alluding to Neurath's famous boat metaphor. Neurath throws empiricism overboard, meaning that since protocol sentences can be accepted or deleted according to rules that are not public and can't be made public, or that is according to no rules, basically. People are basically just going around asserting protocol sentences without any justification, and that's dogmatism. This, I think Popper assumes that no one could go for, although it might be said that Spinoza goes for that, and might be said that Leibniz, Hegel goes for that. But anyway, I think Popper assumes that, of course, this is no good. We can't have an infinite regress. So that's as far as, like, when we accept protocol sentences, that's the problem. But given that problem, I think Popper, he doesn't say this in so many words, but I think Popper thinks, and the whole issue about wanting to know for sure what kind of things count as protocol sentences, what kind of things count as basic statements, that is that whole first problem that has to do with finding the possible basic statements, only looks like a really difficult problem because we've chosen one of these. Because having chosen one of these, we've said that the protocol statements or the basic statements are a very special kind of statement. Right? Most statements, of course, you can't accept unless you have justification for them, and the justification has to be another statement that implies them. But there's a certain special kind that you don't need that for. Either you're just allowed to assert for no reason, or you're allowed to assert on the basis of your own experience. And so it looks like a really interesting question. Which are those special statements? But Popper says, my view doesn't have this problem. It escapes from Fries's trilemma. And that also, I think, is why Popper is willing to say, whatever kind of statements that we agree to make basic statements, those will be the basic statements. They're not a special kind of statement. That is, or their specialness is created by convention. Not convention in the sense of like arbitrary stipulation, but convention in the sense of us, the scientific community, convening and agreeing to accept them implicitly. right? Of course, we didn't really convene and vote to accept them, but that's what's going on. That's what makes them special. Um, so why is Popper's view supposed to escape from this? Well, it's roughly because the way we escape from dogmatism is not going to be um, by being able to justify everything we say, but rather by being willing to test everything we say. And now we get a version of the infinite regress, but it's harmless. Because the infinite regress with justification says you shouldn't assert something unless it's justified. So all the whole chain back has to be there, so to speak. You have to be prepared to justify it, so you have to know all those things. But the infinite regress with testing just says, I have to be willing to test this, and I'm going to test it by these things, and I have to be willing to test those too, but I don't have to actually test everything. I just have to be willing to test it. As long as I'm willing to test it, I'm asserting it rationally. So there's no actual infinity here, as Aristotle would say. So the basic statements are things that we've all agreed, that we all, implicitly agreed, that is, we all kind of expect each other to agree on when to accept them and when not. Right? Like we would be surprised if it turned out that we reported there was this white swan here and someone else reported that there was a non-white swan there. We believe we're a party to a convention to accept those statements under certain circumstances and not under others. But if it comes to it and a doubt is raised, then we say, okay, let's test it. Right? And then, of course, in order to do that, there has to be some other statements that we're going to agree to use to test it. Popper says if it ever happened that scientists on the whole just couldn't agree on any statements, like singular statements, to accept them or not, that would be the end of science. Right? I mean, it depends on that, but that's kind of obvious, right? Of course, science depends on that. So as long as we can find some other statements that we're willing to agree to use as a test of this, then, go ahead, we'll test it. It's no longer a basic statement. We're now treating it as a hypothesis. There'll be new basic statements, which will also count as basic statements until someone raises a doubt about them. And at that point, we'll say, well, okay, let's test them. But Popper says, and, it's not quite as, it's a little bit more, I guess, ironic than I remembered it being. That footnote where Popper mentions Carnap's report of his view, and he's actually pretty nice to Carnap, which is uncharacteristic for Popper, but I guess it's because Carnap was nice to him. So, he says, well, I appreciate that Professor Carnap has reported my view and whatever, but there's some slight differences between us. And basically the difference is that Carnap doesn't really understand what's going on here, because Carnap thinks, oh yeah, so in special cases we'll go back from, let's say, a statement like there's a white swan here to something more primary, like I see a white spot in this point in my visual field. And Popper says, no, we'd never go in that direction. We'll go in the direction of statements that people are more likely to agree on, not in the direction of statements they're less likely to agree on, like, Carl sees a white spot in his visual field at time t. Like, how do we know that? Like, that's really hard to determine. So in effect, Popper says what I said he says before, that yeah, it's nice of Carnap to say that he was inspired by my view, but he actually didn't really understand it. Okay. So there's one more thing I want to talk about, which is Popper's analogies by which he hopes to help you make sense of what's going on here. There's two analogies. One is more interesting. But the other is a better analogy and easier to understand. So the more interesting analogy is the analogy he draws between the way we test scientific theories according to him, or the way we should test them according to him, and the procedure of trial by jury. Right? He says, there's no other statement that justifies the jury's verdict in the legal proceeding. It's just introduced. The jury's introduced it for their own subjective reasons, but that doesn't justify it either. The jury's decision can be used to derive consequences from the law. So the law is like the theory. It's a universal statement. By itself, it doesn't imply guilty or innocent. It implies guilty or innocent only given a certain verdict. So the verdict comes from the jury. And although the jury's verdict isn't justified by anything, it is subject to testing if necessary in a rule-governed way. Right? So I can appeal and say the jury didn't receive proper instructions, the jury, wasn't properly selected, etc., etc. That's supposed to be analogous to the fact that basic statements could be tested later on. There isn't anything dogmatic here, absolutely asserted. Now, it's a really interesting analogy because it suggests all kinds of questions about trial by jury, basically, right? That you can run the analogy backwards. And also because it suggests, again, the relationship between Popper's and other philosophers' views about philosophy of science and their political views. However, it's not a perfect analogy because, of course, what we deduce from the theory using the jury's verdict is not some other jury's verdict. So this process can't be used to falsify the law. It can only be used to declare some individual guilty or innocent. So that means it's not an exact analogy. The other one, which is a better analogy, but which I obviously don't have time to discuss since there's only 1 minute left, or discuss in any depth, is the analogy with proof in logic or mathematics. And there he says, the proof isn't justified by the fact that it convinces us. We accept the proof because it convinces us, but that doesn't justify it. What does justify it? Well, the conclusion is justified by the premises, but what justifies the premises? Nothing, basically. Actually, I shouldn't have tried to discuss this so quickly. I'm not making the analogy right. Yeah, instead you should say, what justifies the whole proof? What justifies us in thinking it's a good proof? And the answer is obviously not some proof. That would be an infinite regress. This is the Lewis Carroll's Tortoise and Achilles paradox. That would be an infinite regress. It can't be that we accept the proof as valid because we have a proof that it's valid. And on the other hand, we're not justified in accepting it as valid because of our conviction that it's valid. But we are rational in accepting it as valid because we're willing to check to see if there's a mistake. That's supposed to be the analogy. All right. And on that note, I will see you on Thursday.